receive the next presenter, Our Lady of Africa, Namilyango, with the project title, Smart Automated Irrigation System using Arduino. Our Lady of Africa, Namilyango. If we can have their presentation on the screen. Our Lady of Africa, thank you. They start. Motivate them, encourage them.
Good morning, everyone. My name is Isinga Praise Kato. I'm from Our Lady of Africa, SS Namilyango. And I'm here to present to you our innovation, a smart automated irrigation system with Arduino. Introduce yourself.
Hello everyone, my name is Nakalyango Maria, still from Our Lady of Africa, Namilyango.
As a team, we identified a problem that Ugandans face too many challenges, unreliable rainfall due to climate change, the current irrigation systems that are there, the methods of, for example, in Uganda there is the drip irrigation system or other irrigation systems which use diesel pumps are unreliable, they waste time, money and energy. So we decided to ask ourselves, what can we do to make irrigation smarter, easier and more reliable? We came up with a solution of an automated irrigation system based on Arduino. The system works in a way in which we use sensors to detect the moisture levels in the soil. So these sensors feed data to the board, and if the moisture level in the soil is adequate enough for the specific crop, then the motor is off. And if it is not adequate, the board, the microcontroller board automatically turns on the motors which will pump water into the soil until the moisture levels are adequate enough. Other solutions in the market include, like I talked about earlier, in Uganda there are drip irrigation systems, there are diesel pumps, there are sprinkler irrigation systems, there are other smarter irrigation systems which can work for large-scale companies or farms but are too expensive, and our solution offers a versatile environment for both large-scale and small-scale farmers, and it's also affordable. Our solution is unique in a way that we use actual sensor data, so we don't need to guess whether the soil needs water or the soil doesn't need water, hence making it more reliable. The solution, it saves water, it saves time, and it reduces the labor needed to carry out the work, making it simpler and easy. The solution also can apply to, it can be powered using solar energy, making it more versatile and be able to be applied in different areas, even in the remote areas that do not have access to electricity. Our team, we designed this project as a team, each of us carrying out the different roles, some making the connections and the research and the programming. Thank you.
Thank you very much for that presentation. Give them a round of applause. Uganda, one of the key economic backbones of the nation is agriculture, and to see solutions that are smart is really helping us achieve our goal of leveraging innovation and technology to accelerate our economy. We would like to hear from the audience. Any comments, questions? The right wing, you've been very silent. Do we have any comments from this side or this side? Or questions from the judges?
Thank you. I think this goes to all the teams. When you are presenting, you have to tell us how your innovation works. That's one. How did you now program? Okay. What software are you using? You know, when you how are you testing it? How much water does it draw? How much does it spray onto the ground? That's such things, eh? So when you just talk about the problem, we aren't as the audience or as the judges getting what actually you are doing. So could you kind of take us through the engineering of your product, the engineering of your product? Not just the science, but the engineering of your product.
Okay, like I said earlier, our project is an Arduino-based project, so we use an Arduino microcontroller board, which acts like the brain of the system. It's where it stores and implements the code for the system. It's one which activates the relay switch in case it receives sensor data saying that the water is inadequate, of which the relay switch opens the power supply to the pumps which will pump the water to the farm. Thank you.
Judges, are you satisfied with that response? Okay, thank you very much to our students. A round of applause once again for the smart automated irrigation system from Our Lady of Africa, Namilyango. We'll now welcome Sacred Heart Secondary School, Gulu. Sacred Heart Secondary School, please take the stage and share with us. Remember the caution from the judges. Yes, we need to know what you're solving, but we need to understand how you're solving the problem. What engineering systems are you using? What tools have you developed? What's the innovation that is allowing you to solve the problem? Thank you.
Esteemed audience, ladies and gentlemen, I greet you all. Via nomenclature, I am Aloysia Gladys, a young innovator from Sacred Heart Secondary School, Gulu City.
And I am Atara Semiodia from Sacred Heart Secondary School, Gulu.
Okay. Our project here presents a smart home automation system with advanced security, GSM alerts, and automatic gate control. Our project is Arduino-based, and the problems that we identified which made us to come up with the innovation is, as we can see, in this modern era, there are security threats in households. There are manual. It might be that there's nobody who should put on their security lights. And from our project, we have a security light which is automatic, which use the LDR, which is the light dependent register, which work on ambient light levels. It works on the basis that when it detects light intensity, it immediately turns off the light emitting diode. And in the evening, when it detects darkness, when there is no light intensity, the LDR will automatically turn off the light emitting diode. So basically, our project is a smart home automation system which is having a motorized gate control. We're having sensor-based buzzer. We have two buzzers, two sensors. The first sensor is at the gate, which detects movement from persons. Like when somebody is coming to close proximity to the gate, the sensor will sense, and immediately the gate will open automatically, allowing the person in. And the gate will also close automatically. Then secondly, we have another sensor from inside, whereby it detects the movement of people in close proximity. And when the sensor detects movement, it will send an alert to the GSM, which is a global system for mobile communication, which is connected to the phone of the owner of the home, and immediately it will send a phone call which will ring to the phone of the owner of the home, alerting that there is somebody or an intruder who has entered the home, making the owner of the home to come and attend to the person outside. Then lastly, we have the automatic light control, which I've explained previously, which uses the LDR, which is the light dependent resistor, which works together with the light emitting diode. Thank you.
Once again, good afternoon. I'm going to bring out the solutions to the solutions that we came out with. So, using our innovation, we decided to come out with the solutions to this problem of security, the problem of energy inefficiencies, and so on. So, in all this, you get that we have used the motor drive that is at the gate side always. When a person is coming in, the sensors will detect and the gate will open automatically. And once the person is in, the gate closes. So with that, we are solving the problem of also hiring workers. Now, when you get in the gate and there is another sensor inside, and that when an intruder is in, the detectors, the sensors, will take in a message to the person who is inside via the GSM, then that person will receive a call that is telling the person there is someone inside your home, you have to go and attend to that person. So, now, she has explained something on how our project works, and I would like to put more on the gates and so on. So, when you come at the gate side, we have placed it at a distance whereby if an intruder comes in, via that gate and stands, the gate will automatically open using the motor drive, and the person will be in. So, and bring it to the light getting on and off. That person will, when the owner of the home is in there, the lights will be on in the night and off during day. That means you'll be enjoying your life wherever you are, knowing that my home is safe.
5 seconds to conclude.
Okay, thank you. As we conclude, our project is unique in such a way that it has a automatic lighting control system. It has a GSM alert which makes a phone call, and we have also automatic security lighting system based on ambient light levels using the light dependence resistor. Okay, thank you.
Thank you very much, Sacred Heart. Let's give them a round of applause for their smart home automation system with advanced security and automatic gate control. Do we have any comments for them or questions? I think all of us have homes, and we're interested in using their solution at home so that we can sleep soundly without any worries.
Yes. How much is your gate?
Okay, thank you, sir. The one we are doing right now is just a model of a smart home automation system. When we advance and we get more funds, we shall now put it into real life situation. Thank you.
Okay, thank you, Sacred Heart. I think that's something you need to think about. How much are you going to sell your product? You need to do some market analysis to understand how much will a typical Ugandan gate owner be willing to pay to access your product. Let's give them another round of applause. Oh, we have one more comment before you go away.
Thank you so much, Sacred Heart, for your presentation. Now, something that has been working in my head, what is your product? We are talking about a gate. I heard there is a lighting system. What is your product that you're selling? And who is your customer, probably?
The product that we are selling is to everyone, whoever has a home, and this project that you're seeing is that, not that when you don't, you can simply have your grass touch house and you put your gate there, but what we need is safety. In the villages currently, you get that during dry seasons, people, if you have maybe an enemy, people rarely, like, I will take my time, I come and burn your house, reason being you're my enemy and I have chaos with you. And that one, you get that even people, it can be applied to people in the villages too, for safety so that your house is not burnt.
All right, thank you. In my perception, according to what I've heard you present, I would think your product would be bought by people who manufacture gates, would be bought by real estate developers when they say they are constructing homes and so forth. They will say they will also have the home automated control system. Yeah? So you need to articulate who your customer is, because there is a customer and then there is a user. The user can be a customer as well, but there can be a developer who is your customer and the actual user is different, is a client of that developer. So you need to articulate what is your product. What is this system? Because you could have a system that you embed in many other physical products to control them. So what is your product? That's the question I leave you with. Articulate what your product is. Your product may not be the gate, but the control of the gate. Thank you.
Thank you very much, Dr. Catherine, for that guidance. And we request that Sacred Heart, please think about those questions and have them answered as you undertake your product development. Let's give them a round of applause as we welcome the next presenter. Chisubi University, please prepare to take the stage. They are presenting a solution aimed at sustainable transport and urban development. Chisubi University. Welcome to the stage, Chisubi University. To all presenters, we have 5 minutes. I don't want to interrupt you, so please try and keep time. And don't forget to introduce yourselves.
Thank you. Protocol observed. I greet you all. My name is Uipe Rogers from University of Kisubi. Yeah, I majorly want to first correct that, not Kisubi University, but University of Kisubi. I'm called Uipe Rogers, and I'm here with my workmate, and he's called
Rogers Kavlet.
Yes, thank you. So we are the two Rogerses here. Our main purpose here is to bring to your focus our project, which is Unique Eco Bike, and according to the slides presentation and arrangement, our problem is high fuel costs and environmental pollution. Then the need is sustainable, efficient, and convenient means or modes of transport. So going into details within that, we have faced so many challenges with buying fuel, and it is true that there have been some alternatives to those, but still they come with costs and challenges, as I will explain as we proceed. Then when it comes to environmental pollution, it is true that most of us have diseases which at times we fail to trace where they come from, because we inhale polluted air. Some are traumatized because of the sound from the previous innovations in terms of modes of transport, and it is true that some people have become sick and have failed to come to their normal senses because of that. So we came to sit down and discuss, and then we had to make ourselves clear that we should make a product that is able to be sustainable, that is cost effective to the environment, and which is supportive in terms of our living, health, and welfare as well. And this product is called the Unique Eco Bike. From the different questions that have arose from our judges, from the presentation preparations, we are not told about exposing the intellectual properties. So I get scared if I'm supposed to go through all that, and yet we are limited to that. So I don't know if it is okay. It is okay. It is not okay. Because the preparation was that we shouldn't expose any intellectual property. But from the questions, it is true that you explain to the deep part of the innovation. Anyways, I will try to panel bit, but in case of any questions, please come to our store. Okay, so this eco bike works in a way that, okay, thank you. Thank you, thank you, thank you, thank you.
Present as you came to present. Whatever you wanted to present, please.
Thank you, please. Okay, so our unique eco bike, I will go, next slide, please. Okay. Okay, I've talked about that. All right, let's go here now. Alternative solutions to the or in the market. I said it is true that we have such kind of innovations and products on market, and it is true that they are working to a certain extent, but ours is made in a way that it shouldn't look similar to what is in market. In other words, it should be more advantageous to what has been in existence already. So it is true that we have electric motorbikes that are on market already, that are working, but those electric motorbikes, it is true that they have limited capacities in terms of distance coverage, speed limit. Then there's an issue of cumbersome charging process. Then after all that, we look at the weights that they carry. Remember, weight of an innovation determines how much it should carry. So our innovation, next slide please. Our innovation has a distance coverage that goes up to 130 kilometers in a single charge, and then it is convenient and efficient with advanced charging system, whereby our charging system is not removable, it is intact. So it is charged when the battery is intact. And then there's no sound pollution, there's no air pollution total. Even if it just passes by, unless you see it, you want to know that something has passed here. That is evident, and we have the product here. Then it takes a full charge of 3 hours when you're charging, and the charging process takes place at any point. It may be your home socket, it may be even via the extension cable. You just put and charge. It's not limited that you have to take the battery here or you have to charge from here. That is limited, and our bike is chainless. Why we focused on that is to eliminate those noise and, the environmental pollutions, because the rotation of the noise of the chain has a level of noise it produces. So this is our unique eco bike, and that's how it looks like. It has been tested. It has an average speed of 100 kilometers per hour. That has been tested on the roads of Uganda. plus the distance coverage. It has a capacity, I think via the slides you noticed some wordings, which was the regenerative charging system. I think the regenerative charging system was beating our heads, but it has capacity to charge itself as it is moving. I know that most people are complaining about that, but it is true because it has been tested. So as a scientist, to come here and say that this and this is true, it means you have gone under a test. So whatever I'm saying here, I mean it and I know what I'm saying. Thank you.
Let's give them a round of applause. Thank you for your presentation, Chisubi. I think we have some questions from the room. Is your bike plug-in, electric bike, or is it swapping? Is the battery charged by swapping? Do you remove the battery, or do you charge it? You've said that battery is intact. Can you please expound a bit more on that?
Okay.
Any other questions in the room as they answer that?
Thank you. Thank you. The battery is intact. It eliminates swapping. That's what I was talking about before. There's no need for you to swap. It has a charging port that enables you to charge at any socket. It may be home, it may be across any shop, anywhere. So its charger is made in a way that it will enable you charge at any point. There's no need for swapping. Then when it comes to the recharging part of it, the extra kilometers, because people will look at the distance coverage as something big. To us, it is not yet complete, but the extra charging process is the one that enables us to beat up a high range of coverage in the process. Thank you.
Thank you very much. You said you didn't want to tell us how you did your work because of IPR issues. And I've seen your bike has got the metal, the battery, the tires, and what have you. So tell us, what part of your bike is patentable? And two, you said your bike goes for 130 kilometers on a full charge. How did you get to 130 kilometers?
Thank you. I was trying to first understand from my colleague if he can do that. So all that, I will first take the first question, the patentship. We have about 3 things on that bike that are under patent. First of all, we have its logo. Second of all, we have the chainless capacity. We have the recharging capacity, and then I think those are the 3. Yes, there are 3. Then when I go to the second question about the distance coverage, I said that we tested this bike. We are from Chisubi along Entebbe Road, but we have ever used this bike to ride it from Chisubi to Mbale City. If you know how far Mbale is, from Chisubi to Mbale City, and riding it back on that very bike, not carrying it on that very bike. So some people will say, now why did you come carrying it? We are transporting it via our university bus because we haven't gotten the number plate to allow it start working on the Ugandan road. So we are eliminating those inconveniences, but we have tested our product. Thank you.
Hello. Mine is a sort of feedback and a comment generally. So there is a better way of presenting and articulating things without necessarily spilling IP. At the end, you mentioned some unique features. If those were very highlighted, for example, on your recharging capabilities, how does that compare with what other people are having? what mileage do you get from that hybrid sort of nature? I needed to know that. Then on the other area, it was around how does your bike compare to the others that are currently there? You mentioned you have a range of 130 kilometers. The current GoGo bikes are at 160. So why would we opt for yours than the current ones on the market? And you can also go and research and see, is having an intact battery an advantage or a disadvantage? Because you will have longer charging times and you will have to wait for a long time. So depending on who you are targeting again, knowing your customer, if your customer is a boda rider, he does not need to spend 5 hours charging. He would rather swap the battery. But so far, this is a very good innovation. And it would also be nice to have a video of your bike moving, like you mentioned it going to Mbale. That gives more evidence. Yeah, thank you.
Thank you very much for those questions. First and foremost, on the capability of charging, we are looking at the costs you would incur putting in fuel time and again. This you could even charge using your solar panel somewhere, and you charge, and you are able to move. But also, we have a mechanism whereby the kinetic energy is converted into electric energy, and in some way, there is no worry that you will take a lot of time charging because of this, the self-charging mechanism. Because every time you apply the brakes, then that kinetic energy is converted into electric energy, which comes back into the battery, and then you are able to go. I hope I have cleared some of your worries. And then you talked about the mileage, the kilometers according to the GoGo bikes, the bikes on GoGo and whatever. You will realize that many bikes, which you would call electrical, they have a motor kind of, which is not in ours. So we don't have a kind of a motor which rotates this bike as it is moving. So there is a very big difference with the GoGo bikes you are talking about. Thank you.
Just one supplement. My name is Geoffrey Mutabazi. I'm an innovator like you, also in mobility. One maybe piece of feedback for you when you're presenting your idea at any other forums would be, it would be really good to have a sort of visual prototype that does help, I would say, showcase the working model or how this works. Even though it's something, done in a rudimentary way, but it does help explain a lot of the direct workings of the idea you're presenting without having to use a lot of words. But really good idea, and I'm glad to maybe give you some more targeted feedback after presentation.
Thank you very much for that
Thank
supplement.
you, Chisube University. Due to time, we shall take those questions. They have a stall at the back. In case we have more comments or questions, please approach their stall. Just to support you as well, please approach myself later on. I work as a Principal Program Officer in the Mobility Bureau and would like to support you to improve your presentation. But most importantly, what you've presented is already available on the market. So it's very difficult for us to take it as innovative. You need to go to the first stall and talk to the people from GoGo, Kara, Zembo, they already have a product that does similar to what you do. So it would be good for you to interact with them and get some insight into improving your solution. Thank you very much. Let's give them another round of applause. We shall have Nishati Mix presenting next. As Nishati Mix comes to the stage, I'll request TDMS to prepare to start their presentation after Nishati, as well as cybersecurity. Whoever is presenting on cybersecurity, please prepare your presentation as well as Nishati Mix takes the stage. Nishati is presenting a sustainable production of real cooking energy from plastic waste.
Good afternoon, ladies and gentlemen. Thank you so much for the opportunity. My name is Daphne Nabiria.
And my name is Benjamin Andruda.
Yes, we are here to present to you Nishati Mix from Tanzania, collaborating with Busitema University. Imagine having waste products or waste plastics turned into clean energy for cleaner cooking and safety. Maybe we can go to another slide. We see that 80% of Africans use polluting fuels for cooking, like charcoal, wood, kerosene, that pollute the environment, bring about smoke and unnecessary pollutants. So we see that there is limited access to actually clean cooking energy in Africa, like the one we are going to present to you today.
About 82% of all Africans use polluting fuels. Take for example, in our homes, most of us are using charcoal, isn't it? Yeah, so we are bringing to you a solution that uses our normal plastics, your normal bottle of Renzori, that can be turned into energy. Imagine converting a plastic to energy. So about 82% metric tons of plastics is what we produce as Africa. And in terms of Uganda, we have about 600 tons per day. That's what we have in Uganda. That's the amount of plastic waste that's produced in Uganda on average.
Yes. So our solution here is based on automation and gasification technology system, where we turn the plastic into LPG for cleaner cooking. We can also get fuel for running stoves and a generator, like any other fuel can do, but this is cleaner and it avoids emitting dangerous gases like carbon monoxide and the likes.
Next slide, please. Yes. So I will take you to how it works. Daphne, can you do us an intro of how our machine works?
Well, this is the whole system, and this is the outlook of the whole system we're going to be taking through. So this is the feedstock, the plastic. We feed the plastic into the system, and this is our startup. Of course, this can act like our button, as you can see it here. The solid residue goes directly in there, then maybe the technical person can take us through the rest of the other things.
Okay, so initially what is done, usually the plastic is burnt, but for us we are doing a pyrolysis process whereby we are introducing the plastic to chemicals that break it down to the liquid and then the gas. So once we get the gas, we can use it for cooking. We compress it and put it in for LPG. Then the liquid that comes, that's the residue. We use it for, you can use it to run your diesel, your generator to give you power, as we shall see in our video.
You have 1 minute.
Next slide, please. Okay. Yes. This is the world market, 2.2 billion people, of course, in the market. Then this is the African market, 900 million people. Well, the Tanzanian market, where it actually started from, we have 56 million people. And best as of Uganda, we have 45 million people. And we see that in the potential uptake in Uganda, we can have around 10 million people using plastics on a daily. And since they had already introduced to us that we use 600 tons of plastic that are produced probably every day. So yes, our market growth, the global waste to energy market was valued, that's $35.1 billion in 2020, and it's projected to reach 50.4 billion by 2028. Maybe something else we didn't put here, something small. A machine could go for $200. That is 760 Ugandan shillings. We also have stoves that could go for around $800. That's 30,000 Ugandan shillings. And the fuel that comes from it, or the LPG that comes from it, could cost around 0.6. That is around 2,800 Ugandan shillings. The last slide, please. This is our competitive analysis. We see that we have a high calorific value compared to other LPG competitors on the market. Yes?
Charcoal, wood,
yeah, charcoal, wood, and the rest. The normal LPG that is ongoing has around 46 megajoules per kilogram, while us we are around 49 megajoules per kilogram. And the more high calorific value, the better and the faster you get your food to be cooked, or you get your food to be ready. The last slide. Yes, this is the team. Thank you so much.
Thank you so much.
Thank you so much, Nishati Mix. We have comments to the innovators. If you can, feel free to bring your prototype to the stage.
Thank you for your presentation. Can I see that slide with the project team? System control, could we see the slide of the project team? Okay, thank you. Are you coming from Tanzania?
We are not. We're coming from Uganda because the head, our CEO, is currently engaged in another conference, so we were requested to represent the team.
Okay, is it from Tanzania?
Yes, it's from Tanzania, and we are rolling out to Uganda.
Okay, so
Yes.
what is your contribution as presenters? What is your contribution in this innovation?
So our contribution as presenters, we want to roll out the project 2 in Uganda. We have presented it also in Busitema University. We're also doing research with them. So we want to extend the project from Tanzania to Uganda.
Beyond extending the project,
Yes,
in
please.
development of this innovation, what is your contribution? Are you just team members extending the concept, or you are part of the development?
I personally am part of the finance, then she is part of the marketing. The rest
Okay.
are technical, yes.
So the technical issues of this innovation, you
Yes.
are not part of its development?
We are part of it. And that's why we have explained it. We are part of the technical too.
Okay, no.
Yes.
You know, science demands truthfulness.
Yes.
Okay? So it is all right if you are just here promoting the innovation. It's all right.
Yes.
So that's why I want to get the ownership.
Yes.
Today we are in this forum. You present this as your own. We are here as judges, kind of attributing this to you. Then tomorrow, another African says this was my development.
And
so I just really want to know the ownership of this innovation.
So we mentioned that clearly. We said we are part of the team. So as we said, everyone can bear witness. We said the innovation started from Tanzania, and we are part of the group. So that was what we mentioned. It was clear enough.
Okay, now.
Yes.
This looks like a solution beyond energy.
Yes.
Is a solid waste solution.
Yes.
Now, we talk of circular economy. How much do you generate of the waste after this process?
Yes.
How does it affect the environment eventually? Are you doing 100% consumption of the waste and not generating anything, any emissions to the environment, or you are releasing some proportion? So if you have done an analysis of its impact on the environment, what is it?
So from the project, we are it's not 100%. So, but the percentage of wastage is less. I mean, the percentage of emissions is less. So it's, we could put it at about 1%. Yes, 1%. 1%.
So what are the products I've seen in your video?
Yes.
There is light, and I saw a liquid.
Yes.
So what are the products?
So one is the liquid, which is used to, it could be used to run your generator to give you the light. So it's the liquid that runs the generator to give you the light. Then you could use the liquid for your stoves, as we talked about the stoves too, or you could use it to run your gas burner.
Okay, there have been so many efforts to deal with plastic waste. What are those other competing solutions of solid waste management, plastic waste? You know,
we have seen groups that have come up with I think it's called tiles, yes, tiles, that are making tiles, and some are making decorative artifacts and sort of things. Those are the ones that we've seen so far.
And energy related?
Yes.
Yeah, I think we've seen that.
So how different is yours from those other energy related solutions of plastic waste management?
So, most of them are not focused on providing clean cooking solutions. For us, we are providing both clean cooking solution, and we're also giving you light. So our competitive advantage here is we are offering two products at the same. So you could either use it to cook, or you could use it to light your system. So some are using just their systems just for cooking, and others are not providing light. So we are using both. So we are giving you light, and we are also giving you energy to cook.
Okay, my last question. What are the challenges you have encountered in compressing this, generally transforming that, getting that gas and storing it? What are the typical challenges in achieving that?
So one, it's especially, as we said, we are trying to reduce emissions. So usually the challenges come into reducing the emissions. Sometimes you have a lot of residue compared to the output that you would get. So we are doing more research to ensure that we have 100% clean solution.
Okay, mine is a question or a comment. You don't have to answer. So one is, how do you address the problem of aggregation in terms of these plastics? Despite them being around, you'll find they are scattered. And so that will always limit your input into your industrial process. The other one is, LPG is already existing, and the problem is around access and distribution of these LPGs. And we even have oil. So how do you plan on addressing this? Are you going to set up mini manufacturing lines for each community, or you will also face the same challenges LPG is having of distributing to the actual homes?
So on the first one, in Tanzania, they are doing a credit model, usually whereby you register on an app if you're a person collecting the plastics. So we give you credits, you earn some credits. It's a two-way. You earn something so that we also earn something. You're collecting, we are receiving the plastics, and then we do it to the end. So it's a two-way. The community is benefiting, we're also benefiting. So that's how we are doing it. And then you said LPG, well, definitely we also plan to set up our own plant here soon. Yes.
Thank you very much, Nishati Mix. Let's give them a round of applause all the way from Tanzania and coming to stores near you soon in Uganda, hopefully the entire African region. We'll take 2 more presenters before we break off for lunch. I know you're all famished, but bear with us. We'll receive TDMS, temperature and dust monitoring system for coffee storage warehouses. Please take the stage with your presentation.
Greetings, everyone. Before you is Frank Muhindo and my counterpart,
Katoko Luanja Lilian.
Yeah, so today we are here to bring to you our innovation. That's the temperature and dust monitoring system, which is AI powered, basically for coffee storage. But this system is as well tailored for any other crop, not necessarily coffee. It is scalable. My friend here is going to introduce more about the problem statement and all the rest that we are currently solving.
Thank you. So basically, I'm going to start with the reason why we chose coffee first. Apparently, Uganda exports around 6 million bags of coffee annually. That earns it around 1 to 2 billion USD. And this contributes around 20% of the export earnings. And then, why coffee? It's because it supports around 1 million and above smallholder farmers, and that's why we decided to concentrate with it. So I'll go into the problem statement, and this is the coffee storage challenges. We were majorly looking at post-harvest losses caused by storage conditions. So these losses are around 10 to 20, but they keep rising up. And these are caused due to temperature fluctuations in coffee warehouses. We have temperature fluctuations, humidity, and then dust. With all this combined, it can result to mold. And those are losses that we are talking about, the ones that occur in storage facilities, mold, and then they reduce the bean flavor. They also reduce the quality, which will also, when we see further, it will also affect our pricing as the nation when it comes to coffee prices. So in our system, we have realized we lack real-time monitoring when we come to what is done on ground. Most people look at warehouses as dark rooms that are not given that much concentration. They only open them when they need to get something from it. We really want our system to actually help with this problem with real-time monitoring and AI insights. And then we also have, can do the solution.
Okay, so basically this is our innovation here. As you can see, we are here to come up with an AI-powered coffee monitoring system. So we are basically trying to monitor the quality and ensure that we are having proper quality of the coffee. So here we are having our TDMS, what you see there in blue, is what we also are having at the exhibition point there. We're having a mobile app. That mobile app there, it's basically there for offline capabilities for our users. Then we are having the website as well. So let's leave that as that there. So we are also having multilingual and voice support. So a user can utilize his own local language. So far we are having 3 languages, that's English, Luganda, and then Swahili. So you can, as we say, this is AI powered. So you can have to, it's all connected into the system as well. So the AI, you're accessing it through the website and the website. So what the user, basically this is all about the local user. So we have tailored our system such that even it caters for a local user. As well, we're also having language as well translation in it, whereby a local user can use his own Luganda to preview all the content that has been translated into Luganda, that's the dust levels and everything. Then as well, I talked about the AI predictions. The AI predictions, this is all about maintenance, right? It will give you recommendations on how to clean your warehouse, and then basing on the sensor data that has accumulated onto our sensor. Are we together? Sorry about that. So basically, when the dust accumulates onto our dust sensor, this dust here, through some predictive analysis, we are able to calculate it up and then tell you that we expect, are we together, about 10 days for you to do some cleaning, basing on the sensor data collection, sensor dust accumulation onto it. On top of that, we also have predictive alerts. The predictive alerts, these give us what is expected to be the next temperature in about 30 minutes or 20 minutes, but most especially 1 hour. So right now you can be, like for instance, this room here has a temperature of about 25 degrees, or maybe 26 degrees. So with that, basing on the previous readings, we're able to predict what could be the possible next upcoming temperature or humidity, and what should the user do next. So everything is in the mobile app and the website as well. Next slide, please.
So about
30 seconds.
About the languages, we have English, Luganda, and Kiswahili. I've forgotten about that. So about the existing systems that are on market that are dealing in something in relation to us, but not exactly what we do, we have Airco Uganda. It monitors dust and air quality with sensor networks and predictive models. We have Energy Monitoring Limited, provides real-time monitoring and alerts. We have Nanosoft, Agrotech, and World Solutions, as you're seeing them here.
Next slide. Next slide, please. Quickly. So this is basically what makes our application and our system and all our innovation very unique. One, we have the AI-powered insights with predictive alerts, as you can see, accessibility features for inclusiveness. That is to say, as I'd said, we have language translation for even the local users. As well, we have a clean UI that even a local user can use. Then we have predictive cleaning. I'd explained that. The multilingual support for the Luganda English and then Swahili. Voice assistant, you just speak and then you get recommendations. You ask anything that you have on your mind about coffee, you're going to get responses. And then we have offline mobile capabilities or functionalities, whereby a user can still use his mobile phone to monitor the temperature and dust in everything. So here we have, I remember that I said that our system is basically scalable. You get that? It is basically scalable. Here we started off with coffee because basically we have to get the threshold values to start testing from, because if you come to bean seeds, they have optimum temperatures for storage. You get that, plus humidity and then dust. But all you have to know is that our system is scalable to all coffee, all seeds, all cereals in simple terms.
Thank you very much. Could you kindly tell us where you're from and your names?
Yes, basically that's the team. It's me, Frank Muhindo, the lead innovator, and then Lillian, she's here. We are basically from UICT, Uganda Institute of Information and Communications Technology.
Thank you very much. A round of applause for the team developing the TDMS. Any comments or questions from the audience? Okay.
Okay, thank you very much. My question is on the specific problem.
Yeah.
You mentioned that the problem is warehouse maintenance, but you had a solution, dust and warehouse maintenance, but you had a solution tackling translation. Is that part of the problem or not?
No, we are bringing accessibility features to the local users because obviously most systems are in English. So how will a local user use our system too? We have to reach out to the local user, bring it in a language he or she understands, such that he or she can use our system.
Okay, thank you. So there is another problem that the farmers don't get English.
Yes, because most systems, as I'd said, utilize English as the best language.
Okay.
But we are bringing the product in a language that they best understand, such that they can use our product better.
Okay.
Yeah.
Yes, so my other comment is, have you validated the problem in any way?
Yes.
So I think the whole system is majorly a predictive maintenance bit. Like the more the dust accumulates, the more the days to cleaning. This goes away with permanent workers in the warehouses, or maybe even those warehouses that are not cleaned. 2 months in, 2 weeks in, people assume like the warehouses are okay, but a lot is happening more. So this real-time monitoring helps you analyze that there is 4 days to clinic, or maybe if the day has been a dusty day or within those 2 weeks, it reduces to 1 day, so you can call in the workers to do that.
Much, TDMS from UICT for your presentation. Let's give them a round of applause. We shall proceed to the next presenter from Mountains of the Moon University, and they'll be presenting combinatorial cold store with a decked 4-for-1 crop dryer. Let's clap for him as he takes the stage from Mountains of the Moon in Fort Portal.
They have I'm Professor Kant Kanyarusoke from Mountains of the Moon University, Fort Portal Tourism City. I'll present to you a new innovation, in fact an invention, on a 5-for-1 cold store with decked night-day solar crop drying. It's a combinational unit. What are the problems that I'm encountering? They are basically post-harvest losses. Post-harvest losses of fruits and vegetables, and post-harvest losses of cereals and tubers. The people, the stakeholders involved, farmers. One, they are forced to sell their products typically at a loss. Two, small produce handlers. These, when they buy produce from farmers, they are forced to rush to sell it before it gets spoiled. Three, you have consumers. These are forced either to consume contaminated products leading to health problems, or they are forced to avoid them and therefore have nutritional issues. And then fourthly, you have national economy managers who have problems in exports. You know that, for instance, our maize was rejected by a number of countries some time back. Okay, so there is issue on export. There is also issue on garbage management in the cities. The Kitaz issue that we had last time partly comes from that. When you have a lot of garbage in the city, rotting fruits, rotting vegetables, that's what they eventually lead. Next. Of course, there are causes, which I have mentioned there, that the causes of this crisis are mainly due to, for fruits and vegetables, it's their perishability. They perish quickly. And the farmers, ideally those should be handled immediately after harvest. but most farmers can't do that. Then on the dry side, the main cause there is that the produce is normally harvested at high moisture content, which encourages mold growth and eventually contamination, encourages contamination by aflatoxins. So what is our solution? This is, ladies and gentlemen, this is the solution. You have downstairs, you have a cold room. Upstairs, you have a drying room. And in that case, heat is normally pumped from the cold room to the upper room. But in the upper room, other things, very many other things happen. You get heat from all directions, from below, from the sides, from the top, from this top, and from that top. So you have 4 additional sources of energy, and most importantly, those additional sources are free of charge. Free of charge. Next. So there are alternative solutions on the market. Okay? But most of these, none of these does what we are doing right now. Combining the two, both cold storage and drying in one place, day and night. In one machine, day and night. Nobody else in the world does that except us right now. The systems that exist as independent. We have already designed we've put up a factory, a solar drying factory at Busitema University, where we were with my colleague. You can see it down there. Now, what we have done is to improve on that and incorporate cold storage. Next. Next. Okay? So the uniqueness of the invention, you can see. Nobody else is doing that. A system which takes in paid for energy at one point, but that single input encourages intake of 4 other sources of energy from elsewhere for free. That reduces the energy cost by between 50 and 90% compared to what exists now. Next. And that's the team. The presenter is a member of ASHRE, a solar energy engineer. I have a doctorate in solar energy engineering, and I have quite a number of inventions in that area. And my colleague, Professor Musinguzi, okay, he's also a sustainable energy engineer, and we work together. Initially, both of us were at Busitema University. Now we are at Mountains of the Moon University, and pushing the limits of usage of sustainable energy beyond people's normal imagination. I thank you.
Thank you, Professor, for the presentation. Do we have questions or comments for Professor?
Yes, thank you, Prof. Now that we know the system works, what is the cost of your system? Then 2, how much energy do you need to do both the cooling, the freezing and the drying for a unit volume of crop produce?
Beginning with the unit volume. Now it depends. Don't talk of unit volume. Talk of unit mass, but even that mass, you have to look at its moisture content. You have to look, so it varies. It's not straightforward that I have 50 kilograms, so it will take so much. 50 kilograms of what? And at what moisture? And you want to dry it at what level? That's the point. So different products, even in the cold room, different products are stored at different temperatures. Okay? So, and they have different specific heat capacities. So it's very, very difficult. But basically, to give you an indication, The unit which is shown on the in the slides, it's a 2 meter by 6 meter by 4.5 meters high. Okay, its drying capacity as designed now is about 220 kilograms of cassava. 220 kilograms of cassava, okay, per day. On a sunny day. On a what? On a sunny day. So I have products here. We've dried cassava, we've dried meat, we've dried chicken, we've dried mushrooms, we've dried matoke, we have dried almost everything. Okay? So that's an indication. But don't take it that if you are drying coffee, you'll put in 220. If you are drying rice, you'll put in 220. No. But that's an indication. How much does it cost? Okay. You see, we have made, outside there is a 20 million shilling small unit, model, okay, for demonstration. It's outside there on our store. But the big one, okay, cost us 47 million shillings. But remember that is in development. So when we refine the manufacturing processes, when we start prefabricating and all that, prices will come down. Now, get it very clear. We are not necessarily making for the peasant farmer. As I've said in my previous innovations and inventions, the peasant farmer will never afford some of these. So we cannot be held like that. He will never afford it. So we design things for big people like you. Who can afford them?
Yes, Prof, what I meant is a company in Ntungamo is trying to process coffee, and they want such big machines for drying coffee. Now, what as a user or an investor wants to know is what's the efficiency of your tool before I buy it. That's why I refer to the volumes, the masses, and volumes of moisture retention and losses, like that. I mean, I'm coming from that angle of an investor who wants to buy your machine.
I understand that very well. But the point is, we have a table of equivalence. We take maize as equivalent, and then cassava, so from such and such a moisture, this is the amount. Coffee, from such and such a moisture, such and such a content, this is the amount for per square meter of drying area. So then you see, when you get to this, then you get the whole. In fact, now the next thing we are doing is to automate it and also put their indications that, look, put their keyboard. If I want to dry coffee, okay, then I type in coffee, okay, and then it gives me, the whole thing is set for coffee. You understand me? That's our current stage right now. Okay? Yeah.
Thank you, Professor. We have one more comment, then we shall go to the next presenter.
Thank you, Professor, for your presentation. I see your solution is applicable in handling horticultural produce, and you could even make products ready for the market. I am concerned about your team. Your team doesn't seem to create an avenue for knowledge transfer and utilization. You are two strong people. You are coming from the university. There is no student in your team. Why?
You see, first of all the way from Busitema, in fact, not from Busitema University, all the way from Cape Town, where I was. Students have always been part of this. In fact, let me tell you, the dryers and the silos that we are now making, we are already making dryers, not this type, but others. Dryers and silos. These are being made by a student-led company. I don't know, some of my students are here. They are at the store. Yes, there he is, okay? That's a separate company, okay? So they are making those dryers as we talk now. They are making silos now, and soon they'll be making these cold rooms. So, I mean, incidentally, I'm writing a book on rural solar industrializing of Uganda. Okay? Their company runs purely on solar energy. It's somewhere deep in the village. The nearest electric pole is 5 kilometers away, but they are running these things here. You can see they are branded. Okay? They are branded. This meat is okay, here, this one is not branded, but this particular package is not branded, but elsewhere it's branded. So they are running it. So don't you worry. I'm after transforming this country right from the village level. Okay? Don't worry about that.
Thank you, Professor. I think what we would like to see is student recognition in research and development. Like Dr. Catherine was saying, you've indicated 2 names, but I'm sure you're not doing the projects alone. And this will motivate students to get involved in research and innovation. So student recognition, and this goes to all the universities in the room. The good thing, majority of the presenters before had students, so we couldn't ask this question. But we would really love to see the students that are supporting you behind the scenes recognized as partners, if it's a company that's partnering with you, or if it's research associates on the project should be recognized. This is a take-home, Professor. You don't have to respond. And let's give Professor another round of applause. Thank you for the presentation. We've had the judges ask most of our presenters about intellectual property, and I would like to inform the people in the room as well as the innovators and the students that if you need more information, mentorship on intellectual property, that includes patents, trademarks, copyrights, utility models, industrial designs, please go to the booth on the left from Uganda Registration Services Bureau. We are conducting an intellectual property clinic, and they should be able to guide you and assist you and advise you on what type of intellectual property you can register for your products, whether it's a patent or a trademark. And they'll also give you the clear distinctions and differences between those different types. So I know you're all hungry, but bear with us. Lunch is not yet ready, so we shall receive 2 more presentations. They've asked us to give them 30 minutes. So we'll receive 2 more presentations, and then we shall break off for lunch. So allow me to welcome the team presenting the facial recognition project. Facial detection, car-based security system for preventing car theft. Please welcome the team from that project. Kindly introduce yourselves and where you're from before you start your presentation. And you only have 5 minutes. Thank you.
All protocol observed. My name is Katwe Jacob Membe, and we are from UICT. I'm here with...
Good afternoon, everyone. I'm Nambi Rehma from UICT.
Yes, our product is about a facial detection car-based security system for preventing car theft. Let us wait for the slides. Yeah, so before I start, I want to pose a simple question to you all. Are you a car owner? And are you scared of your car being stolen in Kampala? or any other area in Uganda? Are you scared for the signs where they put parking at owner's risk? If you're that person or an aspiring car owner, you should listen to this. Next slide, please. So the problem being solved here is majorly car theft, and statistically, over 5,000 vehicles were stolen in 2024. That is from TM Africa. Then only 2,447 recovered, with that number missing. So let's go about why current security measures fall short. So basically, traditional locks and alarms are easily bypassed, okay? And there's also human error. You can forget your keys in the car, whereby to access it, then you have to go to somewhere in Tiseka to access your car. We have high theft rates, which erode trust in existing security systems. So we present to you the facial detection car-based security system. So how does it work? So in our prototype, we have a camera. We have a camera which captures a driver's face. Then it matches it in the stored database. Then only authorized users' faces, which are stored in the vehicle, they're the people to operate the vehicle. The benefits of this product is that you get real-time authentication, introduces false access, and also it integrates with the existing vehicle systems. So there's no need to buy extra systems for this system to work with your vehicle. Next slide, please. So let me leave my colleague to talk about the proposed innovative solutions.
It allows only authorized user to use the car, and it prevents the unauthorized user to use the car, in that when it captures the picture of the authorized user, it compares it to the one in the database. Then if you are not the owner, it will send an alert to the owner of the car. Then it will start a siren or a sound to mean that you are not the authorized user. Next slide, please. Alternative solutions in the market. There is ban for Uganda. In Uganda, there is car alarms. There is CGPS reactive, can be bypassed. Africa, tracker apps, steering locks, costly, require internet, easy to remove, worldwide, biometric, and connected car systems. Expensive, not widely accessible. Next slide, please.
You have 30 seconds.
How is this project unique to the ones present? It allows only authorized user to access the car, prevents theft before it happens, affordable. Then it fills a gap in the market for cost-effective protection. Reliable peace of mind, builds trust and encourages adoption among everyday vehicle owners. Next slide, please. Here we are, but one of us is not around since they told us that we have to be two. One of us is not around. Thank you.
Thank you very much for your presentation. I didn't hear where you're from.
UICT, Uganda Institute of Information Technology.
Okay, thank you very much. How much is your solution?
So currently, we don't have a price set for the solution, for the product. this is just a simple prototype, but I think the cost majorly comes according to your car system. So integrating this system with your Mercedes or with your Toyota, then the prices can't be the same.
Yes, thank you. Again, once more, you've not talked about your project. What have you done? How did you design it? You haven't talked about that too. I have a small car, and an alarm system was installed in the car. But the mechanic told me the people who install these systems are the real thieves of the cars. How are you going to protect my car against you, the thief?
Okay, thank you very much. So let me first answer the first question, how we did this. So our prototype, we use a microprocessor, a Raspberry Pi, coupled with a GSM module. Then we added a buzzer, then some LEDs to show whether the system is scanning, is it authorized or is it non-authorized. We added a small motor system to represent an ignition, car ignition, a car ignition system. Then we also embedded it with a Raspberry Pi camera. Then for programming, we use OpenCV and a programming language called Python. So for your second question, yes, that's true. Most people who do these systems are the real thieves. But we are looking for, like, who's our target audience? Yes, true, our target audience is you, but then we're looking to work with companies like Kira Motors or big companies like Toyota or Nissan, whereby you be assured that when these people put the system in the car themselves, you cannot, someone cannot come out of nowhere and then they steal your car.
Thank you very much. I think you need to do a detailed market study into the type of cars that are driven on the market. Because when someone asks you how much is your system, you can't say if you have a Mercedes, you need to know that data. How many Mercedes Benzes are driven in the country, how many Toyotas are driven in the country, so that you target and develop your solution to meet the widest market or a niche market, depending on your target audience. So you will need to do some deeper analysis, and you also need to work with those corporations and understand if they are actually willing to take on your product or if they don't have solutions already available that they can integrate within their products. So we'll need some more study on that.
Thank you for your presentation. I'm interested in knowing what your product is. The reason is that I do not understand why there is a price segregation, that a Mercedes the system will cost so much for a Mercedes than my Vitz. Okay? If you have the same product and it does facial recognition, why should it be a different cost for one car than another? What is your product?
Thank you for that question. Why we have a difference in prices, this is because the ignition systems of every car, they're not the same. How the ignition system of a Mercedes is laid out is not the same as that of the Nissan or a Toyota or any other car. So integrating this product in those systems, it can't be the same as for any other product. So that's why the prices differ. And also, the question about what is our product? Our product is a whole system. We are selling the whole system. Thank you.
Do you have a prototype?
Yes, madam.
So what does it use for, what does your system use for facial recognition?
It uses facial recognition software for the Raspberry Pi.
Okay, so what is the intellectual property, what is unique compared to other biometric recognition systems that are existing?
Other biometric systems are using, some are using Wi-Fi, but this doesn't use Wi-Fi. That's one of the uniqueness of this product. It's independent.
So you've developed a new software.
No.
What is new in your development?
Maybe I'm not getting your question right.
This is a new solution. I can't quote right now, but facial recognition exists.
Yes.
Are you getting something existing and changing? What is new that you're creating that brings you here as a new system you're creating for protection of vehicles, for facial recognition?
Okay.
So I'm thinking it's the code that they're putting in the software that's actually unique to their product. Am I right?
Yes.
Yeah. So I think that is what actually they're bringing on table for us today. And just to confirm, I can access the car, but I cannot drive it away. Is this what this product is?
Not really. According to what you want, the camera can be placed on your door or
So
inside
it
the
won't
car.
open.
Yeah.
So it won't open. Okay.
Yes.
Also, where does the ignition comes in? I think if it does not notice the person who is driving, who is going to actually start the car, it won't start. Am I right?
Yes.
Okay, thank you for your presentation. I hope you've taken note of the questions. I think some of them should help you improve your solution. It would also be interesting to see the limits of your presentation in terms of data storage, how many people can be, how many different biometrics can be stored. Some cars are used by multiple people, families, so it would be interesting to see that as well. So thank you. Let's give them another round of applause. We shall receive our final presenter for this mid-morning session, Annie Scholar, sorry. Can we receive Annie Scholar as our final presentation? Please don't forget to introduce your project and where you're from, as well as your name, before you start presenting.
Good afternoon, everyone. My name is Joseph Luswabi. I'm the CEO of Annie Scholar Career Hub, but as well as the co-founder of Africa's #1 early talent platform. Next slide. So we are facing a silent crisis amongst the Gen Zs. What crisis is it? It takes about 19 to 20 years for someone to actually accomplish their degree or any learning, looking away all the way from kindergarten to the highest level of learning. However, there is a high lack of work readiness and career readiness amongst these young graduates, engineers inclusive. The other is there is a huge disconnect amongst the industry and academia, whereby someone is just learning whatever they are finding, but they cannot connect it to what exactly is in the industry. According to the recent reports looking at the National Planning Authority, they released that there is an increasing or overwhelming lack of work readiness, work ethics amongst the young graduates that are actually existing in the ecosystem of Uganda. The African Development Bank report of 2023 indicated that only 20% of the 12 million students who graduate annually in Africa make it to the industry of exactly what they actually studied for. The next slide. So, Annie Scholar is actually the solution to this increasing crisis of the Gen Zs. How are we doing this? We are a digital platform that is connecting the students, but also enhancing their work and career readiness. Then we connect them to the industry. How best are we enhancing their work readiness? So a student is going to come to the anischolar.com, they create their profile, then they are able to actually undertake the work readiness short courses. The key skills that are actually missing are the soft skills, but also they get connected after becoming work ready to the industry of their interest. The industries are able to come and tap into a network of over 20,000 young talents that are actually work ready in less than a week. Isn't this amazing? The next slide. So, yes. Back. So, Ani Scholar is actually focusing to create a future where every student is work ready by the time they actually accomplish their degree. And our vision is to see that we give the young talents the key soft skills that are essential, get them visible to the industry, and then connect them to the industry of the various opportunities. Already, this is what we have. Our technology is already 80% accomplished. We have been able to onboard more than 20,000, reaching out to over 10 institutions of learning in Uganda. We don't leave engineering aside. We have them as the first priority, but also we have been able to launch a work readiness and employability program looking to reach over 25,000 students in these other institutions of learning. Our focus is to see that 50 to 60% of these are actually females. The next slide. Who is our competitor, or who are the alternative solutions existing on what Aniscola is doing? First, we have Brighter Monday in Uganda. However, our minds are a bit big. We are not looking at the job recruitment. We are focusing on career and work readiness. We have Handshake in the United States, in Tansala, in India, and then LinkedIn, which is actually one of our competitors because we don't have these same services or our local industry in the existing ecosystem. The next slide. So, what makes Aniscola very unique? Because we are focusing on the student, where we are enhancing the career and work readiness, but also focusing on the early graduates. This makes us very unique. The other is we are looking at increasing the visibility of these young work talent to actually the industry, who are very much of importance. And the other is to see the traceability, which is of very, very vital importance to the institutions, but also to the industry that are getting these young talents on board. The next slide. So, our call to action, whoever is listening to us, we are looking for you to come on board as an industry partner, and we are looking for 10 of you to come and walk the journey with us. How? Come and sign up after this discussion, visit our store there, so that we can be able to onboard you. The other, we are looking for partners who are able to walk this journey with us to see that we actually create, or we tap into the untapped into resource, which is the young talent, by empowering them and also getting them into the next market, which is the job market. The next slide. We have a very brilliant young team, which is very enthusiastic, where I am the team lead, but also the CEO. We have Dr. Olivia Cage, who is the co-founder, but also the operations lead. Vision, who is our tech developer, and Omondi, who is basically leading the industry onboarding. This discussion is very important because we are speaking to you who is in the industry, and we need to have you on board. The next slide. This is basically wherever you are, you have a smartphone, gun type aniscola.com, and this is exactly what you're going to be able to see. The portal for the students, where they are able to come on board, and then they are able to actually have their various designations, and then the industry, which it will take less than 24 hours if you come on board, so that you can have the right talent. Thank you very much for listening to us, ladies and gentlemen.
Thank you very much for that energized presentation. Let's give him an equally energized round of applause. I think you woke up most of the people who are slumbering. And just to remind you all that the top 5 pitchers for that day will receive an award that will be disclosed at a later time. So please pitch with your hearts, just like he did. We welcome some comments. Yes, we have a comment over there.
Yes, thank you, presenter. I'm Twine Blair Freedom. I'm a production engineer, roofing rolling mills, Namamve. Now you have talked about students taking about 20 years in their academic journey, which is a long time. So I don't know if you are focusing on reducing that time, and if you are taking in people to train, at which level? You are starting from high school level, you are starting from campus. Then another issue I would like to understand, how are you training these people? How are you making them ready for employment or for innovation? Different from other companies like Brighter Monday and other things. What is your uniqueness? Thank you.
Yes, thank you very much. So, as Annie Scholar, we are focusing on helping these students launch their careers. There are three careers that actually exist that someone, as a student, could undertake. One could be 80% are looking for employment, about 10 to 15% are looking for actually doing their business, or they are looking at the entrepreneurial line, and also some others are looking at advancing their journey in academia. So what Annie Scholar does, you're taking 20 years. Our focus is, can we have a work-learn environment? So as soon as we are going, as soon as early secondary, where we are actually helping them to make the right choices, because currently there's a lot of evolution that is happening in the job market, and we are still on the things that actually they taught us. There's a lot of revolution. So starting from the career guidance. The other is, once someone comes to the university, start now to actually get you exposed to the industry. Don't just study and then say, okay, I'm doing civil engineering, let me first study, I'll go out later. What Annie Scholar is saying, with roofings, we can actually partner today so that the students, as early as year one, they actually are able to get exposed through volunteerships, internships, or any early career opportunities. And also appreciating it's always a One Health concept. There is not just that you'll find an engineering company with just one engineer. So looking from sales everywhere, the more the exposure, the more better actually we can develop our careers. Thank you.
Thank you very much. It would be, you've analyzed very well the demand side for jobs and the Gen Z market. It would be interesting to see the supply side. How are you linking these students to the companies? How are you engaging the companies? What's in it for the companies? But at the end of the day, what's in it for you? Because at STI, all innovations must commercialize. How are you making money from these students? Are they subscribing? Are they paying school fees? Same question.
Okay, thank you. So when a student comes to the Annie Scholar Career Hub, they are able to undertake some of our preliminary soft skills courses, such as communication, design thinking, because we are not engineers. We are not going to tell you how to do the bolt. We are giving you the key people skills that are actually being looked at from the industry. The hard skills are got from the institution of learning. So we are not replicating. So once someone actually undertakes this, right now we are developing our locally available or entailed, let's say, the employability curriculum, where someone, if they undertake it, they're actually work ready by the time they finish it. For example, if someone undertook the short course on business management, by the time they finish, they understand exactly how our ecosystem for an entrepreneur could actually work it out, because these are not things that are actually out there. So the other question, what was it? The money. Interesting. So for every company that comes on board here right now, 1 million at a discount for a full year. And then you're able to tap into the young, work-ready, trainable talent, which we already have. For the students, they are able to subscribe right now at a subsidized cost of about 50 to 100 Ugandan shillings a year.
I would just like to commend you for this app, because this has been a problem for the last 20 years or so, to have a conduit between the students and also finding an area where they can actually specialize and also where they can harness their talent from. So I'm hoping that this app can reach out to so many other individuals and other students out there, so that from first year they can actually know the direction they want to go with the internships. So I'd really like to commend you.
Anyone on LinkedIn here? By show of hands. We are creating Africa's LinkedIn.
Thank you very much for your presentation, and let's give him another round of applause. And for the companies that would like to enroll onto the app, please reach out to him. I think he has a stall right here in the middle. Roofings, you had a brilliant question, so I think we'll expect you on their app very soon. And the rest who are present with us here. Thank you all for the first session of the Innovation Forum. This concludes the next session. Let us break off for lunch. We'll have a brief lunch of about 40 minutes, and we'll be back here at 3:15 sharp. Thank you all. Innovators, please pick your lunch coupons from Miss Charlotte Chirabo. She's wearing a shirt like the one I'm wearing right outside as you exit the plenary. Thank you all for coming, and we hope to see you in the next 40 minutes.
Please, you have 5 minutes, and I'll give you a warning when you have 1 minute left. You switch on that. And the IT, please help us display Chambogo University Kid Infant Incubator.
Okay, as we wait for the ICT team to display our slides, Baraka Harris Chambogo. So my name is Baraka Harris from Chambogo University. Along with me, I have my colleague.
Good afternoon, everyone. My name is Dong Aljuna Isaiah from Chambogo University, the Department of Mechatronics and Biomedical Engineering.
So what we have brought is a KID, a transport incubator, a low-cost dynamic transport incubator. Next slide. It's there to help us save lives, and also with a mobile and more affordable and reliable neonatal care solution. Next slide. So the problem is that we have a lot of deaths around Africa as a continent, but we are trying to minimize these deaths of infants, yeah? The main reason is that the incubators, they need an incubator that will actually help regulate their body temperature, their vitals, and also their humidity. But these are expensive, they're not easily seen. And next slide, please. And when you bring that problem into Uganda, let's localize that problem. we have 19 deaths per 1,000 births. That means we have 20,000 deaths annually. 20,000 deaths that would be students, would be politicians, would be scientists, would be the next generation of great thinkers that are actually dying. The next slide. So our solution here is...
Okay, so our solution here on the technical side is a neonatal infant incubator like my colleague just described. The goal of this incubator is to provide stable conditions for premature neonates. They usually have challenges with thermoregulation and breathing. So we're trying to build a value chain in Uganda itself. There are solutions that exist right now on the market. Next slide, please. On the market that provide these very similar specifications. But the challenge is they have a high acquisition cost and maintenance cost. So our question was, how can we as young innovators build the capacity for manufacturing and design within Uganda itself for our context of products? Next slide, please. So as you can see, we're trying to build from the ground up, list our specifications as we can design them, and then work towards that goal. Next slide, please. So this project has been in development at Chambogo University under the Department of Mechatronics and Medical Engineering for a while now. We managed to secure some funding from the university itself and a competitive grant that helped us to design our very first prototype. We had several iterative stages trying to utilize different engineering programs, different skill sets that we have amongst our team to come up with a comprehensive design that's cheaper to manufacture than something else that would have been made by someone else in another country. Next slide, please. Okay.
So what are the alternative solutions at the market? Right now, if you look at Uganda, we have only imported incubators that are there. So these are expensive, that is above 7,000, and those are going to be the low-end incubators. And above that is roughly around 35 and above, if at all you're including taxes. Within Africa, our neighbors in Kenya developed a DIY, a wooden box that would help. Also within Uganda here, Africa, we have radiant warmers. And globally, we just have now incubators. For example, the General Electric Healthcare, the drug transport incubator from Germany. But these are not designed with Africa in mind. They are designed with Europe in mind. So what we are going for, what makes our product unique, the next slide, what makes our product unique, next slide please, is that we are making it at a low cost, less than 2,000, the previous slide. Okay, so what makes us unique is that we are having a 70% cost reduction. Reason being is that ours is at 2,000 or 1,500, that is depending on the tiers we have. It will be working reliably on batteries and solar energy because we are catering for even the health center ones, those that don't have the equipment and also don't have access to electricity, reliable electricity. So let's have them run on batteries and also power via solar. Also, the AC, if at all, the alternating current for our normal use. We're making it small as possible and lightweight. Reason being, this is a transport incubator. If someone has given birth in a health center one, we are transporting that one to a health center for if at all complications arise. So we want this incubator to fit inside an ambulance and be moved. Yeah. So the other thing is that we are making it locally. So it's locally available, locally assembled, locally designed. And also making that we are focusing neonatal care, not only in hospitals, but also when they are in transit. Next slide. So what makes us be able to compete with the ones that are existing? Next slide, please. What makes us be able to compete is that we are making ours affordable, we are making ours portable for movement, we are making ours very usable for our layman clinician. And also we are getting these features that they want. They be like, the Europeans have these features, but we also want them to be like this, yeah? And also we are making it reliable, that it won't only depend on electricity from the mains, but also from the others, yeah? So our business potential, we are looking at the sub-Saharan African market, which has over 5,000 health centers, 4s, 3s, and 2s within Uganda alone, and making ours very, very, very affordable. We already talked about 75, but we can increase this deduction up to 80%. Domestically made, jobs within,
and also designed for Africa in mind. Also, we are localizing now the business potential. Let's go to the next slide, please. So we are making sure that all our Ugandan health centers, from the FOS, Health Center 4 and below, should be having at least one kid infant incubator. The potential is to make sure that at least 500, greater than 250 facilities are reached. And also it aligns, of course, with the Sustainable Development Goals. We are talking about us being under the UN, us being under African Union, the Vision 2060. We are making sure that ours is going to be aligned with also the development goals, both within the continent and within the globe. So
Left. 1 minute left.
Okay, in this last minute, I'd like to highlight where we are right now in our process of production. So far we have a roadmap that we're trying to follow to produce this very first prototype. Our goal is, like I said, to build capacity in terms of manufacturing of medical equipment. So we want to release at least 4 prototypes and be clinical trial ready by the 4th. So far we are working on our very first prototype. You'll check out our stall and see what we've actually managed to do with the help of facilities like Uganda Uri in Namamve. They help us carry out some of the fabrication. Also our lab at Chambogo and several other stakeholders. Next slide, please. Yes. In terms of support, we're requesting for $100,000 in seed funding to help us complete our first prototype and also iterate onto that one for the very next one. Any support that you can send forward will actually be very helpful, even if it's technical expertise or even just advice. Next slide, please. This is our team. We have Dr. Roland, who is helping us at the department. And then there is Mr. Baraka Harris over here for electronics design, me as the structure designer, and then other 2 colleagues of ours doing firmware and clinical liaison who aren't available with us today. Next slide, please. Yes, you can go to the very last slide. Yep, so these are our partners that we've been actually working with in the development of this project. In case you want to contact us, there's going to be contacts available. Thank you very much for paying attention.
More vibrant hand clap to the team. So thank you very much, Chambogo University. I would like to give an opportunity to the judges to ask.
Thank you, Harris. You said that you want at least every health center to have at least one. Did you make an accurate assessment of how many we need? Because I'm asking myself, if we have only one and there are more than one such birth at a time, how will you choose which child to put in the incubator? So what is the basis of that having one? Or would you want to make an accurate market assessment so that you find out what your actual market is? Thank you.
What I meant by saying let every health center below the health center force have at least one was that these are transport incubators, meaning they are doing a duality of functions. First of all, it is an incubator as an installation, yeah, and also an incubator that can be moved. So if at all the health center 2s, health center 3s don't have those available facilities, we would maybe transfer them to either regional referral or a health center 4 that would have an incubator installation like that. However, what we are looking at is making sure that we are having accessibility to these solutions, that at least even the grassroots person has access to an incubator. And if the access can be taken, like if at all you give birth, if at all a woman gives birth, yes, gives birth, and then they have to be referred to, let's say, a regional referral, Mbarara regional referral. They don't have to move the baby without any support. So our incubator helps also that they have given birth at health center 2, health center 3, let them move with the baby and the mother to a health center 4 that has a NICU. A NICU is just a neonatal intensive care unit. That is a very great establishment and also has the trained personnel for it. So maybe the initial care given to the infants would be done at health center 1s, and as they are referred to the upper health centers, let's say the health center 2, health center 3, and then also to the regional referrals that may have a capacity to handle those critically ill patients. But this is just our first. We are not going to shoot at the moon and then say let every health center have 5 or 10. We are trying to be as realistic. Yeah, with the funds that we have gotten, basing on the funds that we have gotten and basing on the funds that we are projected to get, let's have at least one health center, health center 3, health center 2, and health center 1, have at least one, and we can build up as we build capacity, as we also build what? The industries that will actually be mass producing these devices. So I hope that answered your question.
There's another question from one of the judges. We have 2 questions from the judges. I'll start with one.
Okay, thank you very much. My question is on cost. How do you plan to drop the cost? I would recommend that not to appear as a factor, because there are very many factors that influence cost. If you want to reliably produce a working prototype, let that not be your limitation. Let quality be the factor you're looking at, because with cost, there is a mass production. There are a lot of factors that are in play for you to validate that it's actually cheaper when you start producing at scale.
Yes, thank you very much for that pointer. Maybe just to expound on how we are anticipating cost reductions, we're trying to, like I said, building from the ground up. We're using an iterative model of design, whereby we use CAD tools to actually do most of the design before we go to manufacturing. You find that most innovators in the country that are coming up, and even out there who are already working, they tend to head straight for production, where they test an idea once and then go for production. For us, we had several design stages before we reached this particular one. So if we had gone ahead and implemented all those previous designs, you'd find that we'd spend significantly more in this prototyping phase than at the very end. So as we consider the fact that maybe in the future we'll have economies of scale working for us, for now and at the base level, we still try to incorporate all those things of utilizing CAD software, utilizing simulation, and doing those tests first before we go and then produce something that is not as efficient as we want it to actually be. Yeah, just to expound on that.
It's a quick one. What can you patent on your product?
So what you're looking at is the patentable, or where we would get our IP from, would be the firmware, first of all, because everyone has different control strategies within what is on the market. So if ours, of course, is not going to, it's an industry secret as per now, because we are quite developing, but once it's fully developed and we are entering commercialization, it should also be a part of the patenting. The other thing that we could do is the design. Ours, as my colleague has said, we have begun from the ground up. Our design would not be actually a patent, but it would be an industrial design. So we'd apply for an industrial design IP protection, yeah? So we would go for industry IP protection. The other would also be the firmware and also the electronics, because the way we are also having our electronics, that's why if we at all you look at what we displayed, we didn't show you the PCBs and everything, yeah? Whatnot. Reason being is that those are our patentable components in our solution, and that's why we couldn't disclose them before we actually do what? Do the patenting. So the firmware, the electronics, and also the control systems, and also the industrial design for the incubator. And also the incubator as a whole, we would get it as a utility model, because this is something very new within Uganda itself, yeah? And within the region itself. So we would get a utility model for our solutions. So those are the various avenues on which we would actually protect our intellectual property.
Yeah, because of time, and I need to go to the next pitch, I'd like to end here the questions. Let's give another round of applause to the team from Chamago University. And I would like to welcome Lukungiri Technical Institute to run over and share more on the plastic melting furnace innovation. Lukungiri Technical Institute to present on the innovation plastic melting furnace.
Thank you, the speaker of today. Protocol observed, I greet you all. In front of you is Njimba Kule Edwin, a student from Rukunjeri Technical Institute. Besides me, I have my colleague.
My name is Atoya Bowen. We are from Rukunjeri Technical Institute. Good evening.
We are here to talk much more about plastic recycling. And here, it has been confirmed that over 8 million tons of plastic wastes enter oceans annually. Hence, these wastes harming marine life, contaminating the food chain, and affecting the human health. And here now, we are talking about the food boxes you have at your places, those plastic food boxes, the small plastic bottles. Instead of throwing them away, we are here to solve that problem in that we recycle them, make new reusable products like pavers, tiles, if I can mention a few. And now, according to the market of recycled plastic is growing rapidly, driven by increasing demand from industries such as packaging and textiles. With the right technology and partnerships, we can capitalize on this trend and create a profitable business. Much more will be talked by my colleague.
Thank you. Now, for me, I'm talking about the production line. This is whereby we first go and select the plastic that you are going to pick. So when we get the plastic, we have to first organize it because these plastics come in the very different categories. Some are PET, PE, PP, HD, PE, and all the rest. After selecting them and organizing them appropriately according to their categories, we have to first put them into the melting furnace. After the melting furnace melts them up to the molten state, we shall vent them into the plastic molds. When they reach into the plastic mold, they will take up the shape of the plastic mold, giving us the paver that we were looking for, any other house decoration. Next slide. So now currently the plastic melting furnace is built whereby it has to raise the temperatures up to the melting point of these plastics. So these plastics can melt starting from around 180 degrees Celsius to around 280 degrees Celsius. So when they have reached that melting point, they are easy to modify and put into these plastic molds. Next slide. Yeah. So now currently the market we have that is currently working in these plastic recycling processes, there is Biofusion that is currently in America, and we also have La Fabrique in Kenya, but they are currently using more of modification whereby they add sand or something else to modify their products. But currently for us, we are looking more to reducing or eliminating the problem of the plastic pollution. So the people that stand into the plantations and look upon all the waste that is in their plantation, the landfills, people like in Fiji, people at Mount Everest that are facing all these problems of the unrecycled plastic that is laying around. For us, we wish to bring them this portable melting furnace whereby it can be set up anywhere and it works on single phase. So since it works on a single phase, it can even go in any normal socket like our house or any other place, meaning that the plastic fumes that will be thrown away can be modified into other reusable materials. Next slide. Yeah, so currently we are still hustling a little bit with the financial part of it, but obviously with time we shall see how to modify about it. Next slide. Yeah, so we were talking about the way it can be sustainable and how it can help in the economy. Currently, this plastic can be sold And the plastic pavers can be sold and we get more money or revenue out of it. For beginners, consider somebody who has to get sand and get the cement to make the normal plastic pavers has to incur more cost than somebody who has to get the already thrown away plastic, melt it, make it into the same paver that is something around 3 times as strong, has his own product, and at a much lower cost. So we were just inviting anybody like an investor or anything like that, because this thing is a very promising thing, and currently there are not very many people currently on market who are doing what we are doing, and at the long run we are protecting our planet and we are protecting our waters and our land, and it will all be beneficial for us at the end. Thank you.
I guess they have concluded. Let's have a hand clap to Kongiri Technical Institute. Yes, I would like. So, I'd like to welcome questions from the judges. The microphone is on your table to the institute.
Yes, thank you very much for that good presentation. My worry is we lose focus. What are you making? Are you looking at the furnace or looking at the plastic pavers? If it's a furnace, can you go and give us the engineering behind that furnace and what's unique about the furnace? Or if it is the pavers, can you go back and tell us what is unique about the pavers?
No, our point is all about the recycling part of it. All the other parts are a way of modifying them, and then later the outcome is the pavers. Our major focus is all about the recycling part, as my colleague had mentioned at first.
Just to advise, when you go back, can you try to refocus your project to something in particular? Maybe a product. Talk about how do you make plastic pavers. As simple as that.
Okay.
Thank you for your presentation. I want to clarify or add on to what my colleague has said. You are talking of pavers, you're talking of a portable melting furnace, okay? And you're talking about pavers. Now, what is your product is the question. You know, you can become emotional about plastic waste and so forth, and you get lost in describing what the problem is than explaining what your intervention is, which is your innovation. So if it's the furnace to melt plastic, what are the characteristics of that furnace that define it as a furnace for melting plastic? Because there are existing furnaces for various tasks, for various applications. There are other furnaces that may not be suitable for melting plastic. So if you are designing a furnace to facilitate recycling of plastic, you need to define that furnace, design that furnace, ensure the specifications are aligned to melting of plastic and dealing with the associated issues with melting plastics. For instance, the gases that come that may be dangerous to the environment. How do you capture them? How do you collect the melted plastic? How do you keep it at a temperature that makes the plastic recyclable? So the issue of the furnace is what you should be developing, okay? Its application is then the melting of the waste plastic to transform, to make it possible to transform it into the pavers. But your product will be the furnace, understood. And if the product is a paver, then we'll be talking about something else. I hope it's clear now.
Yeah.
serve them.
No, is there